Hello everyone. Today we have LeetCode question number 153, finding minimum in rotated sorted array. First of all, we understand the problem, then we think about the solution. Uh, we have a rotated array like 3, 4, and 5, and 1 and 2. Like you can see, we have array uh, rotated like 3, then 4, then 5, then 1 and 2. Like if we rotate this in 3 times, then we make it 1, 2, 3, 4, and 5, like that. So what we can do is we have to find out the minimum element of the array, return the minimum element of the array. This is our problem statement. And we have to you uh, run our code in the big of and log n time. We can't use big of n or uh, like that complexity. We have minimum complexity. We can use big of 1 and big of uh, big of log n, not more than that. Like we think brute force solution is the we have sort the array like 1, 2, 3, 4, and then 5. Then we return the minimum value. That is the brute force solution, but it take big of n complexity because the sorting all the array, it's required the big of n complexity. But in this case, we have a rotated array. Rotated array that it's in mind. We have a approach of a binary search. Binary search. Binary search have a functionality to if we find out the uh, element in the array. Like we have a 3, 4, 5. Then binary search, using binary search, we can easily find out any element in the log or big of log n complexity. But binary search required a two things. If we have a array sorted, then we implement binary search. If it is not sorted array, then we can't use the binary search. If we have a sorted array, and second thing, if we have rotated array, then we also use a binary search. Like that in this problem, like we have rotated array like then 4, then 5, then 6, then 7, then 0, 1, 2. After 4 rotation, we make it is a binary sorted array. In this also case, we can easily implement the binary search, and then we find out a minimum element of our array, then return that in big of log n complexity. Uh, so easily we find out how we can solve the problem. How can we apply a binary search? Binary search is easy to implement. We have to make a one uh, lowest value, then highest value, then we find out a mid value. How like we if we start with if we take example of this example number 3, then we easily find out a low. Low is 11, then 11, and index is a 0. Uh, like we can take indexing 0, 1, 2, 3. And then we have find out a high. High means highest element and last element of the our array. How we can find out? We can make a nums dot size -1. If we can use that, then we find out a last element indexing. Then after that, we can find out a mid element. How can we find out a mid element? Mid element is equal to low plus uh, I minus low by 2. One is the we can add the I and low, like I plus low, then divide by 2. Then it also, but if we have a higher value, then we use this formula, because in this case we can exceed our limit. Then we use this formula. This is a formula that we can apply it in any limit, uh, any higher limit. Then we can write a one code for the our example. First of all, we can take a example number second. It is a good example. Like we take a nums array. It is equal to 4, then 5, then 6, then 7, then 0, then 2. Uh, on 4 rotation, we can sorted that array. But in this case, we can how can we apply binary search algorithm? Like we can first of all find out a low, low is equal to 0. Then we find out a I, like I is equal to the first index in 0, 1, 2, 3, 4, 5, and 6. We have a 6. Then we find out a nums dot size, nums dot size. Nums dot size is equal to, we have a size of 7 element, like 3, 6, and 7. But we have to find index number 6, then we minus 1. And then we find out a mid element, like we can find out a mid element. Mid is equal to uh, low, low plus, like we have to formula low plus I minus low divided by 2. We have low is equal to 10, we have 0 plus minus uh, 6 minus 0, then divided by 2. Then we easily make index number, find out a mid index is a 3. Then we have a mid element is a this one. Then we find out a on which direction we have to move, on this direction or on this direction. We can see we have a mid element of array is 0. Then we make a one condition for that. Uh, if uh, if mid is mid is greater than uh, our higher value, like higher value, then we move in this direction, like this direction. Uh, we can see we have uh, uh, it mid is equal to 7, and higher is 2. It is 2, then it is greater than 2, then we move on this direction. After that, we find out a mid, also that mid. Then we check condition and greater or equal to, and then greater than equal to. Then we lower value on 0. Then we return the lower. Again, we code write that we have first of all we find out the low, then high, then we make a while condition. Why while condition? If low is less than high, then we move that case. If low is greater than high, then we stop that loop. After that, we make a one mid for that. Then make a if condition same as like that, like we have made that. Mid we can mid low is equal to mid plus one, like that. Eh, we can make array, use array, and delete this array. Then if case like this, like if we take 11, 13, and 15, 17, like 11, 11, 11, 13, 15, 17, 13, 15, and 17, like array like this, then we have find out a mid element like this. Then we move to the this thing, because the our smallest element, we can check if uh, mid is not greater than our high. Then we move to the this direction and check in this condition, like make a if condition, then else condition. Then After that, moving all the element, we uh, uh, completed while loop. Then we easily our low value is on the lowest element of the array. Then we return the nums low. Nums low means the lowest element of the array. We can easily find out the minimum value of the our array. Uh, so its state complexity of big of log n, and we can easily pass the our test. It is a very classic and uh, simple algorithm by nature we can use in this question. Let's run this code on the lead code. I write code on the lead code. Like we make a one low, then high, then we make a condition. Low is lower than the high, then we run a while loop, then we make a mid element of the our array, and then we make both the condition if and else. If for the if mid is greater than the higher, then we move low to the mid plus one. If it is lower than the mid, then we make a mid minus one for I, and then return the low value. Let's run it. Okay, we pass the all three test cases, visible test cases, then we submit the code. Oh, we have to submission in our uh, test cases. Let's see what is the problem. Uh, Expected is the three. Then our I think we have to make one more condition uh, uh, for else if uh, how we can do is we can make a one more condition. Like if we have a element like three one like three one and two, then how we can do? Like if we have 3, 1, and 2, then is uh, mid is a mid is lowest. Mid is a mid is a lower than high, and the mid element. Uh, like we make a condition for nums mid is greater than uh, nums high, and and then okay, got it. Like we make a one more condition for else if for that. Then we make a condition like nums uh, nums uh, mid mid is uh, mid is lower than nums of nums of nums of high, and then we make nums mid is lower than uh, lower than less than mid is nums of low. Then we return our mid. Okay, let's uh, let's run this uh, condition for that. Like we make a else if nums nums mid is less than nums of I, and uh, nums nums mid is less than nums of low. Then we can uh, return nums mid. Okay, that's it. Okay, we can do test this. Okay. We have some problem. And that's fine. Okay, we can check where is the problem in our code. Like mid mid is high to uh, mid is okay. Let's see. Where is the problem? We have a we can check mid is equal to 1. Uh, Mid is a greater than high, lower than high. Okay. And mid is a greater than low, greater than less than low is greater. High is greater. Okay. Let's submit. Okay, we have some problem on other test cases. Okay, we have problem in the like this case. We can do mid minus one, but we don't do that. We're not mid minus one. We can make higher on the mid. That is the problem I can see. Uh, like we can do is the uh, I is I point to the mid minus one. We miss the middle element. We can remove that mid minus one. Then only we can use mid for I value. That's easily passed out test. Let's run. Let's submit. Okay. We can pass out the test cases and final submission. Thank you for watching my video. If you like my video, then subscribe my channel.